Okay, now let's solve this problem. The problem is you have to find out the solution using the Laplace transform. Although it's not written here, but we will be using the Laplace transform in order to find out the solution for this problem. Solution should be in this form. What is x, or the displacement of this system in the time domain? This is my concern. So let's find it out. And in order to do that, you see the initial conditions are given, which is displacement initially at 0, time it is 5, and velocity is also velocity is 0 at time t equals to 0. So in order to do that, so let me write this down. Over here you have to take the Laplace transform. First you take the Laplace transform, and then you take the inverse Laplace transform later on. So Laplace of second order derivative is this one. So if you take a look, this is the actually in the table. So as x of 0, this is x, okay, x of 0 minus x dot 0, and Laplace of x dot is nothing but s x of s minus x of 0, and Laplace of just displacement, it is just x of s. Agreed? Now let's plug it in. Let's take the Laplace transform of that equation. So I can write down s square x of s minus 5s minus 0. Agreed? Plus 4 plus 4x plus 4x of s equals 0. Agreed? Now over here let's combine x of s together. So you're left with s square plus 4, and the right hand side is 5s. So let's write down x of s on the left hand side and 5s over s square plus 4. Now this is the same question. You remember I showed you different questions here. This is the same question like we solved over here in the past. So you have to take the inverse Laplace transform of this question. So this will give you the solution of this differential equation. So in order to do that, I would do the this is very easy. If you take a look in the table, this is exactly the form of the table. So can you tell me which form is very close to our question other than 5 scaling factor? So s in the numerator, denominator s square plus 4. So I would say number 11. Do you agree with me? Number 11 is the closest form. So what is number 11? Number 11 says s over s square plus omega square. This is the Laplace transform of Laplace transform of cosine omega t. And if you want to go back inverse, you get this time domain. If you go forward, you get Laplace domain. So let's so if I want to take the inverse Laplace, you will just write down 5 cosine. Now here this is 4, but here this is omega square. What I can just write down 2 square. Agreed? So I can write down 5 cosine 2t. So this is your answer. X of t equals to 5 cosine 2t. In order to plot it, you just have to see. You are not required to plot it by just telling you that this is a cosine function. It is not. It is undamped oscillations. This is not enveloped with e to the negative t so terms. This is undamped oscillations.